Welcome friends in the next session of signals and systems. There are basic operations which are to be performed on the signals, and after performing those operations the signal characteristics will change. So there are two types of basic operations that can be performed. First, the operations performed on the dependent variable, and second, operations performed on the independent variable. Let us discuss first operations on dependent variable. Remember, here we consider dependent variable as amplitude, and so whenever we talk about operations on dependent variable, we talk about the amplitude. So first of all, amplitude scaling. This operation can be characterized by this equation: y of t is equal to c into x of t, where c is a scaling factor and x of t is the original signal. C scaling factor is being multiplied to the amplitude of original signal x of t, and hence a new signal y of t generated. The example of amplitude scaling operation is the amplifier, where output y of the amplifier is given by g into x, where g is the gain of the amplifier and x is the input signal. Another example is resistor. So we can write the equation as V is equal to R into I. Here V is the output signal, I is the input signal, and resistor R value is a scaling factor which is multiplied to the value of current, and hence a new signal called voltage is generated. Another operation that can be performed on the dependent variable is the addition of two amplitudes. Let x1 of t is in one signal and x2 of t is another signal. Then resultant signal y of t is said to be addition of the two signals x1 of t and x2 of t, where the amplitudes are added and new signal is being formed. In discrete time signal, we write y of n is equal to x1 of n plus x2 of n. Example of addition operation is the audio mixer, where it will add voice signal as well as music signal, and a composite audio song we can listen, which is a resultant of addition of various signals. So audio mixer can be considered as the best example to showcase the addition operation which is performed on the amplitudes of the signals. Third operation can be multiplication, where x1 of t and x2 of t signals are multiplied in amplitudes and new signal y of t generated. In discrete time signal, y of n is equal to x1 of n into x2 of n. Example of multiplication operation is the amplitude modulation. In amplitude modulation, this signal is called as a modulating signal, which is a low frequency signal. The second signal is a high frequency signal, and it is called as a carrier signal. Amplitude modulation is the process in which this carrier signal is modulated and amplitude of the modulating signal is taken into account. So you can see in the third signal that this is the amplitude modulated waveform, where amplitude of the carrier is changed according to the amplitude of modulating signal. So here amplitude modulation is the process of multiplication of modulating signal and the carrier signal. Fourth operation is differentiation, and we can write as y of t is equal to d by dt of x of t. X of t is the original signal, and the resultant signal y of t is obtained by taking differentiation of the amplitude of x of t. A good example of differentiation operation is the inductor. So for inductor, we can write down the equation as phi of t is equal to L d by dt of I of t. So I of t is a input signal, and there is a inductor L. So inductor L is taking the derivative of the I of t amplitude and the resultant signal voltage V of t gets developed across it. So this voltage developed across the inductor is given by the equation V of t is equal to L di by dt. So output voltage Y, which is a new signal, is obtained by taking the differentiation of the input signal I of t. Next operation is integration. Equation of integration operation is given by y of t is equal to integration of x of tau d tau. So here new signal y of t is obtained by taking integration on the amplitude of the input signal. A good example of integration operation is the capacitor, and the voltage developed across the capacitor is given by the equation V of t is equal to 1 by c integration I of tau d tau. So in this way, these are the 5 different operations which can be performed on the dependent variable, which is amplitude. I am sure that you understood these operations performed on the dependent variable. Thank you, friends.